Hello, welcome to the next edition of JavaScript Funct-on-ions. Probably the weirdest word that you have probably ever heard made up, but I wanted to find a word, uh, make a word, I guess you could say, that express what is going to try to be done in this series of videos. What the real idea behind this is to give uh, a complete understanding of how functions work, and not only how they work, but also how to understand them from a low level and a high level. And what I'm going to be doing is, the first day I tried to use a visual drawing that I used with my tablet. I didn't feel like it worked out too well, and I wanted to also be able to you look at functions at that lower level from the AST, the abstract syntax. So I've started using the abstract syntax tree explorer. And so what we're going to do is we're going to look at a function that we're going to look at from the Explorer, and also we're going to look at it, there we go, from the from how it executes. So what I'd like to start with is the actual execution, I'm sorry, from the abstract syntax. And why I want to do this is because I think it's important to be able to see how the code that you write is broken down into tokens and then put together for you. What we have here is we have a function with the name addf that takes in a parameter x, and then it returns a function with the parameter y that then returns x plus y. Then when we call it with the argument with a number 5, and then it's called again with an argument of the number 2. So what I'd like to do here, first of all, before we see how it actually executes, is to get an understanding of the actual way that this is broken down. On the right-hand side, you're actually going to see the tree. And then on the left-hand side, when I hover over a particular part of the syntax tree, you'll see that it's highlighted. So what I want to do is I want to look at this, and uh, this is called a program, which in essence is actually what it is that you've already built. So you can think of this as the I don't know, the app that you have created so far. What we're going to do is we're going to step through the body of this program and start to kind of get an idea. So when you hear words that other developers might use, then you'll have an understanding of what it is that they are talking about. If we take a look first here, is that we have a function addf. Now when we see the function keyword before the name, then we are looking at a function declaration. And you'll see here some internal information that is that goes along with the function. And one of those is that we have a type, which is a function declaration. And we have some, so we have a start and we have an end, just in case you might want to know. Those are the tokens. So it's broken down. So you have a F, you have a U, you have an N. With the function declaration, we have an identifier. So with this function, we have named it. And with the name of the identifier is addF. So when you have a function declaration, you have an identifier that is associated with it. Now we can close this up, and then we can look and see that with this function declaration, we have params. And you'll see that in our params, we have an identifier. So you'll start to get the idea of identifiers being the names that have been used for the function, the parameters, arguments. So in this function addF, we have a param that we're going to be passing in, and again, we just have a name for it, and that's X. So at this point in time, we have got ourselves a function declaration that is then broken down into the identifier of the function declaration that has params that has the name of X. So next part of this function declaration is a block statement. And so you'll see here highlighted is the block statement. Interestingly enough, inside of this body, we then have the return statement. So if we open this up here, is that we will see that the type of this is a return statement. And then inside of there, we have an argument. So with this argument, we can open this up and continue to drill down into the tree. And we will see here is that this is a function expression. And so we're actually having the, let's go back up here. We have a function declaration, and then we have a function expression. So here, when we're returning, we have a statement. And with that statement, we are expressing what it is that we want from the return statement. If we go down, we'll see that inside of this function, we have a param. And again, we'll just get used to these naming verbiages. And we have an identifier, which we have named Y. Again, then inside of here, we'll see that we have a block statement. And jumping inside of there, we have one param, which is an identifier, and then we have the name Y. And if we go another level deep, we have another block statement, and then we have another return statement. And here we have a binary expression. And with the binary expression, we have broken down the identifier that's on the left, and we know that the identifier's name is X. We have an operator that's in between, and that's the Y, plus. And on the right, we have another identifier, which is Y. So we've drilled down pretty far into the tree of the syntax tree. Let me just start to close some of this up. Actually, I can probably just go to the top here. So we've declared our function. So now we're going to go and we're going to go into an expression statement. Now, if you want to think about this in the way that you're talking with the JavaScript interpreter, is that you're declaring a function. So you're declaring what it is that you want to be able to do. And then once you have that declaration, once you've declared it, then you can express what it is that you want to have happen. So with this expression here, we have a call expression. And so with the call expression is that we have a callee, which if we open that one up, is that we have the identifier and we have the arguments. So the call E is the actual addf. And so the call E being addf will then be able to identify with what you have declared as a function declaration, which then we can identify with addf. So back into the expression statement is that we've got the call E, which we know is addf from the identifier. Let's close that up. And we have an argument. And the argument is a literal, which is a number. And we have some information that we can find that raw is just string 5. The value is a number 5. So now what we can do is that we can see this argument, and we know that we pass arguments into the call E, which then we'll look at when we execute this, is that then it will go in and it will take the place of the params that we have named. If we go into, let me just go back here, close this up. So in our call expression is that we've got the call E and we've got the arguments. So with the call expression, we first of all have a call E again, which is the identifier, and that's addf with one argument. Now, the interesting part about it is that then we have another arguments, and it's a type of literal with the value 2. Now, interestingly enough, if you look at this, is that the call expression has the call E, which when it is called with the parentheses, and the argument is a literal, which the value is 5. So how is it that we have then another argument outside of this? Well, what we can see here is that we have a value 2, and the thing is that there is no call E for this. So it lives outside of the expression that we have identified as addf. So it's kind of dangling out there by itself. Now, how is that to be? Well, if we execute this function, we will come to find out how that is. But what I've wanted to do here is just to start to give you an overview of what happens underneath of the hood when you actually declare a function and then you actually call the function, and how it looks, the naming conventions, and the information that is available when the abstract syntax tree breaks down into tokens this actual code that you have created. So if we go now over, sorry, I'm showing some of the RxJS I'm working with. Here we have the JavaScript that we have created, and now we're going to be interacting with the JavaScript interpreter. And so what we're looking at here is we're looking at the function that we created and then the addf call E. So let's kind of just take a look at this. Is that we know that JavaScript is single threaded. So it goes line by line for each of the, for all the code, I guess you could say, that you have created. And what happens here is that with the function addf, is that it's going to store this information into the frames, which we have. So the frames is what you can consider to be the call stack. So for example, here we have a frame, which is the call stack for the name global. That global frame is considered to be the window in the JavaScript for the browser. One thing, so a couple things to take notice of is that frames is the call stack. And for each of the call stacks is that this one goes top to bottom. You'll probably most often see bottom to top, but this was the best program I could find that would illustrate how this operates. So what we've done here is that over here you'll see that we have a red line, and then we have a lighter green line. So the red line is the next line that's going to be executed. So this add F has not been executed yet. And then the line that just executed. So we haven't executed anything at this point. But here JavaScript has stopped at this add F, and it has taken that and it is put the name add F, which is the identifier, onto the call stack. So just try to think of a frame, the frames as the call stack, and then this add F is actually put into the global. What happens at this point in time, you'll see that we have not invoked or we have not called add F. So if you were to type add F into your console in your browser, this is what you would get back. You would get the whole function because we haven't called it yet. We haven't put the parentheses after add F at this point in time. Now we're going to go ahead and we're going to execute that. And now that we've executed it, is that we can see that we have the line that just executed, and then the next line that's going to execute. So at this point, we have now taken add F and we have put it onto the stack. And so now it has its own frame, its own stack. Well, what has happened here is that we have taken the argument 5 and we have put it into the placeholder of the argument X, the param X, and now we could just think of X as being the number 5. So the next part is we're now inside of this function with the identifier add F, and now the next thing that's going to happen is we're going to return a function. And let's go into the next. So what we've done here is that we have returned the function. And so in a function, when you return, you're returning a value. And as you'll see here, from this add F, when we return, what we're returning is this whole function. So when we pop out of this add F, is that all we're returning is a function. So we inside of this right now in this stack, as add F is on the stack, is that we've got the number 5 that is associated with X, and we've got a return value, which is this whole function. So now we're going to go back to where we were when this was called. So now we'll see that we're back into the global. And so we would think to ourselves, okay, we have returned the value that is now gone. So how is it that we are able to then execute another execute add F again with the number 2? And what is going to happen? This time we're going to go back into into the function that was returned from add F. Now the interesting part about this is that we returned the whole function back to add F. And now when we called add F again, we stepped inside of that whole returned function, and we're now inside of it. And we will see now that we've got a reference to X, which is 5. And now we've got a new value for Y, which is 2. How is it that we have x when it is not actually a parameter of this function? Well, what happens is that this is what we call a closure, and that is that this function is able to remember the parent value, the parent parameter, x. And the reason for that is because we still have a reference to it. When we returned that value from addf the first time it was invoked, is that the return value was just a complete function. So when we did that, is that we still had x here, which we now have a reference to, and we're able to go ahead and when we move forward, is that call addf again, we still have a reference to x, the parent function. So when we're about to execute this return x plus y, we're still holding on to that reference from the parent, which is 5. And then we have the 2, which is represented here in place of the placeholder y. So now when we return out of this and back to the global, is that our return value is not going to be this whole return statement. It's not going to be x and it's not going to be y. It's actually going to be the value 7 when we actually execute x plus y. So x we know is 5, 2 we know, y we know is 2. And so when we add them together, we then return out of this function, and then we're able to go back to addf that we just executed, and then we're able to have that value of being 7. Sorry about that. So that's my breakdown of trying to explain how JavaScript executes the single-threaded code that you've created, and then from there be able to go back to the first part here, is that then we can be able to step through, and once we have declared our function, is that then we can call it, and then we will go back into that function, and then we will start to return values, and then that will be what we get out of the function addf. So the beginning process was that we were able to take this and visualize and see underneath of the actual code how we are able to, how JavaScript, the syntax tree breaks down the tokens that, so what you see here is not what the interpreter or the JavaScript engine sees. Over here is that you can see what it is and how the program is broken down. So I'm going to continue to try to explain this more in future videos with breaking down functions and peeling apart the onion for these functions. But I think it's important to understand how underneath the engine actually breaks down the code that you have written, and then it is able to interpret what it is that you have written, and then you're able to see how it is that the syntax tree will actually break it down, and then the verbiage that is used. So with the function declaration, as opposed to a function expression. So and then when you actually have a name that is after the function, it's called an identifier. So this is just a basis for being able to understand the verbiage, and then being able to go further into the tree and see how it operates. And then along with that, we're then able to see the whole execution context for this code that we have written. So I'll continue on with another another day of being able to use different code and continue to step forward to where we're going to build out higher order functions and using currying and using monads and everything of those sorts to where we're able to really dive deep into the best parts of functions in JavaScript. Thank you very much.